So this week we're going to be working on factoring polynomials. Last week we worked pretty much exclusively on simplifying expressions. And before we get started, I want to make it clear that simplified and factoring are the opposite, really. If you think about 30 compared to 5.6, 30 would be the simplified form of 30, and 5 times 6 would be the factored form of 30. Because obviously writing it as 30 is simpler than writing it as 5 times 6. Or for that matter, 3 times 10. That would be another form of the factored form of 30. Okay, so even though the theme of this first 3 weeks is simplifying expressions, we could really call it changing the way expressions look. So we're either going to simplify or factor. So this week we're focusing on factoring. However, before we start factoring, we're gonna practice multiplying binomials, because again, the way you factor is by knowing, just like in factoring numbers, the way you get good at factoring is by knowing your multiplications really well. So the idea of this worksheet, it's posted in Canvas. If you want to go through and do the multiplying the binomials, but look for patterns. And I've actually created this worksheet in a way I've grouped a lot of the ones that are similar together. So hopefully you can see patterns. So the idea is you want to work your way through this, doing problem after problem. And as you go, you should recognize some things showing up that are some patterns that'll help you with factoring. Okay. So I would recommend that you, most of you probably can multiply two binomials together, and wouldn't hurt to get some practice at that. So I'd recommend you do the worksheet first and then watch this video, or you could do the a couple lines of the worksheet and then come back and check on the video and just kind of do it with me, so to speak. Okay, so here we go. Here is the first. We're going to do the first couple lines here. So multiplying binomials worksheet. So remember, when you're multiplying binomials, a lot of people talk about FOIL, which stands for first, outer, inner, last. That's just a acronym that helps remind you to multiply all the things necessary. What we're really doing is just applying the distributive property here. So when you have something times something in parentheses, normally the order of operation tells us we have to do the stuff inside the parentheses first. So we should do x minus 4 and x plus 3 before we multiply them together. But we can't, because x and 4 are not like terms and x and 3 are not like terms. So the distributive property allows us to get around that. So as long as we multiply x times x and x times 3 and 4 times x and 4 times 3, we can do that before we add the stuff inside the parentheses. So that's the idea. Okay, so x times x, of course, is x squared, and x times 3 is 3x, and negative 4 times x is negative 4x, and negative 4 times 3 is negative 12. But of course, as soon as we're done with the multiplication, we always check to see if there's any like terms, and there certainly is. The 3x and the 4x. So we get x squared, that would be negative x minus 12. Okay. So that's the idea. So we're going to kind of cruise through these pretty quickly. So x times x is x squared, and x times 6 is 6x. Negative 6 times x is, oops, I didn't write x there. Negative 6 times x is negative 6x. And finally, negative 6 times 6 is negative 36. And we check for like terms, and we see that 6x and negative 6x are like terms, and they add together, and they actually cancel each other out. So we're left with x squared minus 36. Okay. Go to number 3. We got 3x plus 2 and 3x minus 2. So I multiply 3x times 3x, and that gives me 9x squared. Multiply 3x times negative 2, that gives me negative 6x. 2 times 3x, that's positive 6x. And 2 times negative 2, that's a negative 4. Once again, when I look to the middle, there is like terms, and when I add them together, they cancel each other out. So that would be 9x squared minus 4. Okay. Cruise back over here. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. 5 times 2x is positive 10x. And 5 times negative 5 is negative 25. Again, we see like terms, so we combine those like terms and they cancel each other out again. That's a 10 out of 16. And we end up with 4x squared minus 25. Cruising along here, hopefully you see a pattern developing. X times x is x squared. X times 4 is 4x. Negative 4 times x is negative 4x. And negative 4 times 4 is negative 16. Once again, we have like terms that cancel each other out, so we get x squared minus 16. Let's do one more of these. X times x is x squared. X times negative 3 is negative 3x. 3 times x is positive 3x. And 3 times negative 3 is negative 9. Once again, we have like terms that cancel each other out. X squared minus 9. Okay, so let's pause for a moment. Look that over. You might want to pause the video and just look back at what we just did and see if you can see the pattern. Okay, so if you've already taken your time to look at it, notice that all of these end up with two terms except for the first one. So that's a good pattern to notice. So we want to make sure we understand why. So the key here is that the like terms here in the middle did not cancel out, but all the other ones they did. And the difference is that notice in this case the x and the x are the same, but the 4 and the 3 are different. But over here you notice that x and x are the same and 6 and 6 are the exact opposite. 3x and 3x are the same and 2 and negative 2 are the opposite of each other. 2x and 2x are the same, 5 and negative 5 opposite each other. So that same pattern goes through all of them. And so, except for the first one, of course. And so because the first one didn't have a matching thing over, even though they had the opposite sign, this is a 4 and that's a 3. So there end up being a middle term left over. So the thing we want to notice, first of all, is the middle term comes from, and by middle term, in the final polynomial, the middle term comes from adding these two. If we followed FOIL, it would be the outer times the outer and the inner times the inner, right? So this one here, let me grab a different color real quick. Thank you. This one here is the first of FOIL. This one here is the outer of FOIL. That's the inner of FOIL, and that's the last of FOIL. So notice, same thing here. This is first, outer, inner, last. This is first, outer, inner, last. First, outer, inner, last. Getting kind of repetitive here. First, outer, inner, last. And first, outer, inner, last. Okay? So we notice that the first times the first gives us this first term. The last times the last gives us this last term. And the outer times the outer plus the inner times the inner ends up giving us the middle term. So in all of these, when we multiply the outer times the outer and the inner times the inner, we get the exact opposite result. And that's why they cancel each other out. This is what is called the difference of squares factoring pattern. So again, the whole idea is this: I want to be able to go from here back to there. So when I am given a polynomial that only has two terms, then my first thought is this could be a difference of squares factoring pattern. And notice what happens is this 3x is actually the square root of 9x squared, which makes sense because we multiply them together to get that. And also these 2's are the square root of 4. So notice to go from here back to there, I just take the square root of 4x squared and get 2x and put it in both places. Square root of 25 is 5, and I put 5 in both places and put a plus or minus to assure that those middle terms cancel out. Okay, so that's the pattern that I wanted you to notice. Let's keep going so we can see it some more. X times x, that's first times first is x squared. Outer times outer, that would be positive 4x. Inner times inner, that would be negative 4x. And last times last would be a negative 16. These cancel out. We're left with x squared minus 16. And notice once again that 4 times 4 equals 16, and x times x equals x squared. So to go backwards, I could just square root that, put a plus or minus. Okay, same thing, 4x times 4x is 16x squared. 4x times 3 is 12x. Negative 3 times 4x is negative 12. I keep forgetting to write the x. That's embarrassing. Negative 12x, and negative 3 times 3 is negative 9. Middle terms cancel out. I'm left with 16x squared minus 9. And finally, x times x is x squared. Outer times outer is 1x. Inner times inner is negative x. And then last times last is negative 1. Middle cancels. X squared minus 1. Okay, so that's a whole bunch of examples of, we're multiplying them, but if we wanted to go the other way, if we wanted to factor, that's what factoring is, you can see that it's a difference of squares factoring pattern. Okay, so here's a new one. When we multiply this, first thought is x plus 2 squared. You know that you can't distribute the x squared through, or the squared through that. Hopefully we all know that. So the only way to handle this is to go x plus 2 times x plus 2. Because, please excuse my dear Aunt Sally, or the order of operations says I have to add the x and 2 first before I can square things, right? But I can't add x plus 2, so I got to come up with some different way. But when I write it like this, I realize that I can use the distributive property again. So x times x is x squared, x times 2 is 2x, 2 times x is 2x, and 2 times 2 is 4. So this is similar to the pattern we saw up above, but notice it's just plus and plus. So the middle term didn't cancel out this time, right? 2x plus 2x is going to be 4x this time, plus 4. Okay, let's do a couple more. So this would be x minus 6 times x minus 6. X times x is x squared. X times negative 6 is negative 6x. Negative 6 times x is negative 6x. And negative 6 times negative 6 is positive 36. Once again, I have some like terms in the middle, but they don't cancel each other out. They add together to give me negative 12x. And here's another one, x plus 4 times x plus 4. X times x is x squared. X times 4 is 4x. 4 times x is 4x. And 4 times 4 is 16. Once again, we have middle terms that combine together because they're like terms, but they don't cancel each other out. They add together, give me 8x. Again, now that we've kind of been looking for patterns, hopefully you're noticing a pattern, but we'll keep going. This is going to be x minus 2 times x minus 2. So x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Combine like terms, x squared minus 4x plus 4. So hopefully at this point you're noticing that all of these are, you're multiplying two binomials that are exactly the same. Up here we were multiplying two binomials that are almost the same except for their signs were different in the middle. So we'll continue this. That's going to be 9x squared plus 12x plus 12x plus 16, which would be 9x squared plus 24x plus 16. And finally, oh, this is a different one, isn't it? I'm going to stop here because those aren't exactly the same. Okay, so if you look at this, let's look for patterns once again. If you want to pause the video and find your own patterns and then check back again, that would be fine. You'd pause it right now. But carrying on from there, notice the difference. Once again, these are the same exact binomials being multiplied together. So we notice that the middle terms actually end up being the same, don't they? So notice that this, let me grab my red pen so I don't, yeah. So notice that this right here is always twice that number. The coefficient is twice that number because we end up getting the same term in the middle and add them together. So this is a perfect squares pattern. So the x is going to be squared, the 6 is going to be squared, but then the middle term is just going to be twice whatever one of the, either the outer and the inner, right? So this is my first, This is my outer, this is my inner, this is my last. First, outer, inner, last. So again, the pattern is that I notice that if I just break this into, if I was to try to factor it, we know that it would be an x here and x here. This would be a 6 and a 6. And if we just throw a plus, or no, I'm sorry. In this case, we'd put a minus in both cases because of that minus. So the term in front of here tells me what the two signs are. Notice here it was plus, and that was plus, minus, minus, plus, plus, minus, minus, plus, plus. But notice that the last term is always positive, isn't it? Because I'm multiplying two numbers together that are the same. So if they're both negative, I still get a positive when I multiply them together. If they're both, if they're both positive, I of course get a positive when I multiply them together. Okay. So now we're getting into those are kind of some obvious patterns, hopefully they're easier to see. When we get to this one, notice that they're not exactly the same. We'd still want to multiply, but notice you will notice here, since we're talking about patterns. Let me grab my black pen again. So notice that they're all positives though. Positive, 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 positive. And that's the next thing we're looking at. But they are different. You know, we're getting away from the matching binomials. So we go ahead and start multiplying. 2x times 2x is 2x cubed. 2x times 3 is positive 6x. 3 times x is 3x. And 3 times 3 is 9. Okay, and once again, the middle terms are like terms. 6x plus 3x is 9x. And plus 9. Okay, let's do a few more. X times x is x squared. X times 7 is 7x. 3 times x is 3x. And 3 times 7 is 21. Combine the middle terms, that would be plus 10x plus 21. 3x times 2x is 6x squared. 3x times 5 is plus 15x. That square does not look like a square, does it? 1 times 2x is 2x, and 1 times 5 is 5. So we get 6x squared plus 17x plus 5. And x times 2x is 3x squared. X times 6 is 6. Oops. Sorry about that. 3x squared. X times 6 is positive 6x. 3 times 2x is positive 6x. And 3 times 6 is positive 18. And like terms, 3x squared plus 6. Whoops. Plus 12x. Plus 18. What? Okay, so sorry, I just had a little interruption there, and thought I'd turn the recording off, but it kept going. So, okay, let's look for a pattern here. Looks like I'll grab my red pen first. So, the thing we notice once again is that this first term is always coming from the first times the first. And the last term is always coming from the last times the last. And the middle term always comes from adding the two things together. That's the key to factoring. The outer, adding the outer and the inner, outer and the inner together. So when we get to factoring, we want to keep that in mind. That so again, if I was trying to reproduce this factoring, so let's say I was giving this 2x cubed plus 9x plus 9, and I wanted to factor it, I set up my little parentheses and I say, okay, I know that this times this has to equal 2x. There's a cubed in there. Oops, that's embarrassing. Glad I saw that. That should have been squared. That should have been squared. Okay, sorry about that, folks. Okay, so we know that this times this has to give me 2x squared. And my only options really are 2x, 2x and x. And then the second thing I think of is this times this has to equal 9. And now I have a couple options here. I could have 9 times 1 or 3 times 3, really. Okay? So then, how do I know which one is which? One of these has to fit in here and produce a middle term of 9x when I add them together. So notice if I put a 9 here and a 1 here, I get 9x plus 2x, which is 11x, which is not what I want. So, but if I try 3 here and 3 there, I get 2x or 6x plus 3x, which is 9x, and that works. Okay, so that's the idea of multiplying these out so we can get used to that pattern. But notice the other thing I wanted to point out here is since all the terms had nothing but addition in them, notice that all the trinomials have nothing but addition in them. And that will continue. Yep, here's a couple more on this page. Let's recognize that. So notice, so every time I have the same, both a positive and a positive, I'm going to get x squared plus 8x plus 4x plus 32. And notice in my final answer, everything is positive. Here again, we've got nothing but pluses, so that's 2x times x is 2x squared. 2x times 3 is positive 6x. 4 times x is positive 4x. And 3 times 4 is 12. Add the middle term together, and we get nothing but positive. And finally, we get, what, 12x squared plus 6x plus 6x plus 3. And when we combine like terms, we get 12x squared plus 12x plus 3. So again, the terms are the same. I mean, the terms are the same sign in both. The binomials have the same sign in both. They're both positive, and we notice that all across here is positive. So you have a trinomial that has nothing but positive values in it. That means that when you factor it, that both terms are going to have to be a plus in them and not a subtract. Okay? So likewise here, now notice that we're going to do it looking at a different pattern, that we have the numbers that are mixed, the coefficients are not the same, so this is not going to be a difference of squares or a perfect square, but the signs are the same. So we're going to look for the similar patterns that we saw up here. So notice 2x times 7x. Whoops. I'm going to have to pause that. So actually, I think I'm going to stop the video here, and because it's going a little bit long, and then I'll just start a new video taking up here at number 22. So